Okay, problem number one, we're in section 123.3. They're the exercises. My recommendation of some idea what they're asking about, and this is a cubic polynomial, and they're asking about the inferior and limit at the negative root and the superior limit at the positive root. So before you do anything, I hope you have some impression that this is a cubic problem. I see a y-intercept at -4. I know the function is going to be going down at some point and up at some point. What they're asking about is where are the roots? What's the biggest one it could be? What's the smallest one it could be? All right, superior up here, inferior down here. So the way we do it is basically like sign analysis, and I'll go through it. All right, so the first thing I would do is to write a function down. So the function is going to be f of x, and f of x equals x cubed plus 3x squared plus x minus 4. Now certainly, and just in simple sign analysis, I want to point out, if you're looking at a number line and you're going from 0, and I like to look at integers, by the way. At 0, it is definitely a negative number. But what I know, at some point, it's going to go above the x-axis. So I'm trying to find out what that upper limit is, integer-wise anyways. And anyway. So what I'm going to do is I'm going to factor it. And f of x, when you factor it, well, that looks like a tough factorization problem. So I'll just concentrate on this part of it. And what do you have there? X. And then what do I get? I would get x squared plus 3x plus 1 minus 4. And really what I'm starting to look at, I'm starting to look at this thing, and I'm saying, I wonder when it overpowers that and becomes positive. And certainly, you take numbers. Like at 0, I know it's negative. What happens at 1, though? What would it do at 1? So if x were 1, what would I get? I would get 1, and then I get 1 plus 3 plus 1, which is 5. That certainly overpowers it. So I know at 1 it's above. All right, I know it's above. I'm not care about exactly where it is, but I know it's above there. But then my concern is, what happens at 2? And we're getting a feel for it. You get 2, and then you get 4 plus 6 plus 1, 11. It's even getting much larger than the 4. So at this point, I hope you realize it's starting to take off. All right? So I'm going to say the upper bound is 1. That's done. It's right over here. All right, then what do we do? Let me erase all this work over here. We're done with it. What we do to the curve is we're going to rotate it about the x and the y-axis. The reason being is we want the same behavior. What's that behavior? We want that behavior to be like this over here. So we're going to rotate it about the x and the y-axis. So we have to do this. So the negative roots will become positives, but it's still going to have the same shape to it. All right, it's still going to be sailing off in that direction. I'll put my eraser out. Now, granted, mistakes happen. Let's see if I can do this. And I'll do it, maybe I should do one thing at a time, and then I'll write down. Let me do f of minus x first. I would get minus x cubed. We did this when we were doing the quadruple sign, by the way. Plus 3x squared minus x minus 4. Now I'm going to take the opposite of it. What are you going to get? X cubed. Let's see, minus 3x squared plus 1 plus 4. All right, let me get my eraser out. And I think I want to play the same game. All right, and that game is going to be, I'm sorry, this is x. Sorry about that. I'm going to factor out the x again, just like I did before. And you get x squared minus 3x plus 1 plus 4. Now, by the way, my concern now is just looking at integers. At 0, it's positive. By the way, you could use quadratic form. I'm not saying you couldn't, but I don't want to do that. At 1, it's still positive. Now, why is that? 1 minus 3 is minus 2. Minus 2 plus 1 is minus 1. So you get minus 1 plus 4 is a positive number. Now, you start to realize that 2, right? What do you get? You get 4 minus 6. Well, 4 minus 6 is going to be minus 2 plus 1 minus 1. Well, then you can get minus 2 plus 4. It's still positive. At 3, what happens? Well, something interesting happens at 3. That's where this thing is going to become the factor. Anyway, let me point this out. This factor here starts to become positive always. So what do I now know? It's always positive. So what does this mean to me? There are no negative roots. There are no negative roots. All right? So I would list that. Now I realize in my key I made a mistake. This stuff needs to be taken out. All right? Now I want to point out where the mistakes are. Right? The mistake is not here. The mistake is not here. The mistake is not here. The mistake was in my analysis. I don't know how I came up with that, but it's not true. So I'm gonna have to cancel this off. I'm get my little red pen out. Cancel this off and simply say that, let me write this over here. I'm gonna have to state this instead. I'm going to state that this minus f of minus x is greater than or equal. Maybe maybe I should put down the greater than or equal. It's just greater than. It's always positive. All right, always positive. So I'm going to say that what I should have written down, and I'm going to say this says no negative roots. I need to update the key, by the way. Let's look at the picture, though, by the way. And by the way, when someone says, how does that happen when you're writing a key? It happens. You know, I don't know what I was doing, what I was writing down. You know, maybe, I don't know. I can't really explain how that happened. But anyway, looking over here, was the upper bound for the root 1. There are no negative roots, none whatsoever. All right? So the analysis certainly led to that. Okay? Thank you so much for listening. Oh, by the way, I do want to recommend, my name is Ron Bannon, and that's my email address right there. Thank you for paying attention.